Hello and welcome. So today we're gonna see accessing the shell. We're gonna see how to access the shell, what is the shell and everything. First thing first, congratulations, you have just installed Linux. So before we begin, what should you know? So first we're gonna discuss file system hierarchy, then we're gonna see the storage technology and how to use them. Okay, then we're gonna see the boot process. How does the system start? So file system hierarchy standard is a set of guidelines that define the structure of the file system directory tree in Unix-like operating system. It's primarily used in Linux distribution and provides a standardized organization of directories and files, ensuring consistency across different systems. So this is the file system hierarchy of Linux. We're gonna see that we have slash here, we have home directory, user directory, etc directory, root, etc. First thing first, we see here we have this is called root directory. This is the root directory, this is the user root directory. Okay, this is for our user root, this is our root directory. So here is a brief overview of the main directories defined by the file system hierarchy standards. First we have bin directory. It's for essential command binaries. These are programs that are needed in single user mode and must be present for the system to boot. Boot directory. So here we have the bootloader files, the kernel files and other files required for booting the system. Then we have the dev directory. It's for device files. These are the specific files that represent devices connected to the system, such as hard drives, keyboard and printers. etc is for system configuration files. This directory contains configuration files for various system component and application. Next, we have home directory. Home directory, it's user home directories. So each user on the system typically has a subdirectory within home where they store their personal files and configuration. So for every user, we have our subdirectory within the home folder. We have lib and lib64 essential shared libraries. These directories contain shared libraries needed by programs in bin and sbin. We have the media. It's a mounting point for removable media such as USB drives and CD-ROMs. We have a mount file folder. So mount folder is temporary mount point. This directory is used for temporary mount file system. We have optional OPT, optional application software packages. Some third-party software may be installed under this directory. Next, we have proc, virtual file system that provide information about processes and system resources. We have root directory, home directory for the root user, and we have runtime data files, so that this directory contains system information that is valid only for the current boot session. We have system binaries, similar to bin, but contain binaries that are used for system administration tasks and are typically not needed by regular users. Now we start with the storage technologies. So GPT and MBR are both partition schemes used to define the layout of partitions on storage devices such as hard drive and SSDs. So while ext4 is widely used file system in Unix-based operating system, the house example. So the partitioning scheme acts like a blueprint, dividing storage into sections like rooms in a house. Meanwhile, the file system focuses to a kitchen, organizing and managing data which each partition efficiently. Together, they form the foundation for organizing and accessing data on storage devices, much like a house layout and kitchen arrangement, contributing to the functionality of a home. Here we have a table showing us ext4 and older version of extended storage, first introduced in 2008. It was started from Linux kernel version 2.6.19, and it supports use individual file size and overall file system size. Maximum individual file size can be from 16 GB to 16 TB. Overall maximum extended for file system size is 1 exabyte. So the size of the partition, the size of the file that we can save and manage in the system. So this is an example. This is partition number 2, number 1, number 3, and every partition has a file system. We have a swap partition. So in Linux, a swap partition acts as an extension of RAM, allowing the OS to store inactive data. This frees up RAM from active processes, preventing system slowdowns, and proper configuration and monitoring are essential for optimal performance. So you can use your hard drive as memory. Now let's gonna see the boot process. So the boot process is essential for starting up a computer system and preparing it to run the operating system and other software application. So boot configuration is crucial for specifying boot devices, managing boot loaders, and ensuring hardware compatibility while maintaining system integrity and facilitating automation and supporting recovery and maintenance during operating system installation. Usually, if the operating system won't start, it means you got a boot problem. So here we're gonna see the difference between boot legacy and UEFI boot or boot legacy. First thing that starts on the motherboard is the BIOS, and the BIOS what is gonna do is gonna search in the MBR in the hard drive for a bootloader. So the bootloader is a program that after being loaded to the RAM, it will search for the kernel and copy the kernel to the memory RAM, then give it the execution. Then the kernel will start the operating system. Only difference here is that the bootloader is in here. UEFI, Unified Extensible Firmware Interface, is gonna run or start UEFI bootloader, and the bootloader is directly gonna find the kernel and launch the kernel to the RAM. That's during the starting of the execution. He will find operating system and start the operating system. Just so you know, BIOS Legacy and MPR are old. Both of them are old. BIOS Legacy doesn't support booting from GPT with partition table, and UEFI supports both MPR and GPT. So the boot process, boot legacy UEFI. This technology are inside the BIOS if you want to find them. UEFI offer modern features like faster boot time, secure boot, and support for large disks, while legacy BIOS provides backward compatibility with older hardware and operating systems.